Material removal by action of hard, abrasive particles, usually in the form of a bonded wheel, generally used as finishing operations after part geometry has been established by conventional machining. Grinding is most important abrasive process. Other abrasive processes: honing, lapping, superfinishing, polishing, and buffing. Definition: a grinding wheel is a multi-tooth cutter made up of many hard particles known as abrasives, which have been crushed to leave sharp edges for machining. Every grinding wheel has two constituents: abrasive used for cutting point, bond that holds abrasive grains. Basic functions of a grinding wheel: 1. Removal of stock. 2. Generation of cylindrical, flat and curved surfaces. 3. Production of highly finished surfaces. 4. Cutting off operations. 5. Production of sharp edges and points. Construction of grinding wheel. Grinding wheel parameters: abrasive material CI, grit per grain A bonding material sieve, wheel structure ev, wheel grade. Abrasives: an abrasive is a hard and tough substance, having sharp edges. It cuts or wears away materials softer than itself. Important properties of abrasives are penetration hardness, fracture resistance, and wear resistance. Abrasive material properties: high hardness, wear resistance, toughness, friability, capacity to fracture when cutting edge dulls, so a new sharp edge is exposed. Abrasive workpiece material compatibility: affinity of an abrasive grain to the workpiece material is important. The less the reactivity of the two materials, the less wear and dulling of the grains occur during grinding. Abrasive material properties. Types of abrasives: natural abrasives, they are obtained from nature. Natural abrasives are sandstone, emergia corundum, diamond and garnet. Artificial or synthetic abrasives, they are manufactured to have well-defined and controlled properties of hardness, roughness, and type of structure. Artificial or synthetic abrasives are silicon carbide, SiC, aluminium oxide, Al2O3, traditional abrasive materials, aluminum oxide, Al2O3, most common abrasive used to grind steel and other ferrous high-strength alloys, silicon carbide, SiC, harder than Al2O3, but not as tough, used on aluminum, brass, stainless steel, some cast irons and certain ceramics. New abrasive materials: cubic boron nitride, CBN, very hard, very expensive, suitable for steels used for hard materials such as hardened tool steels and aerospace alloys, e.g., Ni-based alloys. Diamond, even harder, very expensive, occur naturally and also made synthetically, not suitable for grinding steels used on hard, abrasive materials such as ceramics, cemented carbides, and glass. Hardness of abrasive materials: abrasive material Noop. Grit per grain size. Size of grain grit is determined by sorting or grading the material by passing through screens with the no of measures per linear inch. The grain size influences stock removal rate and the generated surface finish. The selection of grain size is determined by I. Nature of grinding operation, EI. Material to be grinded, E. Material removal retive. Surface finish required. Grain size: small grit sizes produce better finishes, larger grit sizes permit larger material removal rates. Harder work materials require smaller grain sizes. To cut effectively, softer materials require larger grit sizes. Abrasives are very small when compared to the size of cutting. Grain size: small grit sizes produce better finishes, larger grit sizes permit larger material removal rates. Harder work materials require smaller grain sizes. To cut effectively, softer materials require larger grit sizes. Abrasives are very small when compared to the size of cutting tools and inserts. Abrasives have sharp edges and allow removal of small quantities of material. Very fine surface finish and dimensional accuracy can be obtained using abrasives as tools. Size of an abrasive grain is identified by a grit number: smaller the grain size, larger the grit number. SR, NO.SIZETYPEAPPLICATIONS 1.10, 12, 14, 16, 20, 24 Coarse rapid material removal 2.30, 36, 46, 54, 60 Medium stock removal and finish both 3.80, 100, 120, 150, 180 Fine less stock removal, high surface finish 4.220, 240, 280, 320, 400, 500, 600 very fine very high surface finish, grinding hard materials. Measurement of grain size, grit size, is measured using a screen mesh procedure. Smaller grit size is indicated by larger numbers in the screen mesh procedure, and vice versa. Grain sizes in grinding wheels typically range between 8, very coarse, and 250, very fine. Bond. The bond is an adhesive substance which cements or holds the abrasive grains together to form a grinding wheel. Depending upon the application, bond imparts the qualities of hardness or softness to the grinding wheel. The choice or selection of the bond depends upon the accuracy, the required surface finish, and the nature of grinding operation. Bonding material properties: must withstand centrifugal forces and high temperatures, must resist shattering during shock loading of wheel, must hold abrasive grains rigidly in place for cutting yet allow worn grains to be dislodged so new sharp grains are exposed. SA.No. Name OF bond characteristics designation 1. Vitrified bond good strength and high porosity V. 2. Silicate bond waterproof, used for large diameter wheels, grinding of fine edge tools, etc. S. 3. Shellac bond thin wheels, high elasticity, not suitable for heavy duty application. E4. Resinoid bond rough grinding, high speed grinding. B5. Rubber bond thin wheels, fine finishing and polishing e.g. ball bearing racers. A6. Oxychloride bond disc grinders, less brittle. O. Wheel structure. Structure of the grinding wheel represents to the grain spacing, or the manner in which the abrasive grains are distributed throughout the wheel. The entire volume is occupied by abrasive grains, bonding material and pores. The primary purpose of structure is to provide chip clearance, and it may be open, medium, or dense. Wheel shapes and sizes. The shape of grinding wheel should be such that it permits proper contact between the wheel and all of the permits proper contact between the wheel and all of the surface must be ground. They are classified in the following groups. I. Straight side grinding wheelie, cylindrical wheel, cup wheel, sieve, dish wheels. Grade of the wheel. SR. NO.TYPEDESIGNATIONAPPLICATION 1. Dense 1, 2, 3, 4 cutting and snagging. Hard and brittle materials 2. Medium 5, 6, 7, 8 90% grinding wheels 3. Open 9, 10, 11, 12, 13, 14 soft, tough, ductile materials e.g. ball bearings, brass, bronze. Wheel grade indicates the grinding wheel's bond strength in retaining the abrasive grits during cutting. This is largely dependent on the amount of bonding material present in the wheel structure, VB, measured on a scale ranging between soft and hard. Soft wheels lose grains readily, used for low material removal rates, and hard work materials. Hard wheels retain grains, used for high stock removal rates and soft work materials. Wheel designing. It consists of 6 symbols representing following properties of grinding wheel. I. Manufacturer symbol I, type of abri, grain size IV, grade EV, structure EV, type of bond V, manufacture symbol optional for reference. Grinding wheel specification, standard grinding wheel marking system used to designate abrasive type, grit size, grade, structure, and bond material. Example. A46H6V also provides for additional identifications for use by grinding wheel manufacturers. Example of a wheel specification. 51 A36L5V40. 51 manufacturer's symbol indicating type of abrasive. A. Abrasive, aluminium oxide. 36 grain size, medium. L. Grade, medium. 5 structure, dense, a medium. V. Bond, vitrified. 40 manufacture symbol, suffix, optional. Wheel identification. Prefix abrasive grain size, grade, structure, bond, suffix 45C54H6S23, optional. AAL203, aluminium oxide, coarse 10, 12, 14, 16, 20, 24 soft H. I. J. K. Dense 1, 2, 3, 4 vitrified, V, optional, by C6 silicon carbide, medium 30, 36, 46, 54, 60 medium L, M, N, O medium 5, 6, 7, 8 silicate, S, by manufacturer CCBN, cubic boron nitride, fine 80, 100, 120, 150, 180 hard P, Q, R, S open 9, 10, 11, 12, 13, 14 shellac, E, manufactured E diamond very fine 220, 240, 280, 320, 400, 500, 600 very hard, U, V, W rubber, R, resinoid, R, oxychloride, O. Grinding wheel specification. Dressing the wheel, dressing accomplished by rotating disc, abrasive stick, or another grinding wheel. Grinding wheel specification. Grinding wheel specification. Grinding wheel specification. Dressing the wheel, dressing accomplished by rotating disc, abrasive stick, or another grinding wheel held against the wheel being dressed. As it rotates, functions, breaks off dulled grits to expose new sharp grains, removes chips clogged in the wheel. Truing the wheel. Truing, use of a diamond-pointed tool fed slowly and precisely across wheel. As it rotates, very light depth is taken, 0.025 mm or less, against the wheel. Not only sharpens wheel, but restores cylindrical shape and ensures straightness across outside perimeter. Although dressing sharpens, it does not guarantee the shape of the wheel.